Hey guys, welcome to Homework Help for Year 5, Term 4, Week 9. On page 7, question 1 says, let's find the sum of all the prime numbers from 30 to 50. So prime numbers are numbers that can only be divided by itself and 1. If it has any other number that you can divide it by, it's not a prime number. So for example, number 31 is a prime number because you can only divide it by 1 and 31. Okay. Anything that's even number cannot be prime because you can divide by 2. So we will not look at even numbers or odd numbers. So 31, 33, 35, 37, 39, 41, 43, 45, 47, 49, and I think that's it. Yeah, between 30 and 50. So now 33 is not a prime number because you can divide it by 3 and 11. So then nope, that's gone. 35 is not a prime number, can be divided by 7 and 5. 37 is a prime number, so we can choose 37. 39, nope, divide by 3 and 13. 41, 43, yes. 45, no. 49, no. So these are all your prime numbers. It says find the sum of all the prime numbers, so you're going to add 31 plus 37, 41, 43, and 47. If you add them up, you get the answer. Next one's find the sum of all the factors of 60. Oh, let's have a look at 60. 60 has all the factors. You can break it down to 10 and 6, 2 and 5. Actually, no, let's not do it this way. Let's look at the factors of 60. All right, 60. 1 times 60 is 60. 2 times 30 is 60. Okay. 3 times 10 is 60. 4 times 15 is 60. 5 times 12 is 60. 6 times 10 is another 60. 7, 8. I think that's it. It says find a sum, so you gotta add all these numbers together. Sum means add them all up. Okay, so these are all the factors of 60. There you go. Next one says a rectangular paddock has an area of 240. Find the length if it is 8 meters longer than the breadth. Okay. So here you have your rectangular paddock. Now one side is 8 longer than the other side. Let's see, how do we do this? You can use guess and check, I guess. So maybe 240, maybe one could be 10 and 24. But 24 is 14 more than 10, so that's not gonna work. How about we can try 12 and 20? Oh, whoops. 20 should be here because it's longer, and 12 should be here. And it works. 12 times 20 is 240, and 20 is 8 more longer than the breadth. It says, find the length. The length is 20. Question 4. Find the number between 0 and 100, which is odd, a multiple of 3, and whose digits when multiplied equals 18. Okay, odd numbers, you got 50 of them, so that doesn't really help us narrow it down very much. Multiples of 3, you got 33 of them, so does help, but not enough. But the last one, whose digits when multiplied equals 18. So this one helps us narrow it down a lot better. So we're going to use this one. So you got two. Find the number between 0 and 100. That means that the number must only have 2 digits, right? It's between 0 and 100. It says it should have 2 digits because it says whose digits plural. So it has 2 digits. It can only have 1 digit or 2 digits. But since it's a plural, we know it has 2 digits. So it looks like this. Now these two numbers multiply to give you 18. So let's have a look at 18 and see what multiplies 18. You can have 1 times. Actually, let me just have a look here. Whoops. So 18 can be 1 times 18, 2 times 9, 3 times 6. 4, 5, 6, and that's it. You can say 6 times 3, but that's the same as 3 times 6. So that means that your answer must be either be 1 and 18, but that's not a 2-digit number, that's a 3-digit number, so that doesn't count. So that's gone. Now you can try 2 and 9 or 3 and 6. Now which one of these is, they're both between 0 and 100, so that condition is true. They have to be odd. Odd number, that means it can't be this one, it has to be 2, 9. multiple of 3. Multiple of 3, okay. Okay, that's not gonna work. So let's rewrite the other way. All right, let's keep going. 6 and 3, 9 and 2. Anything else I can multiply 18? 1 and 18, 18 and 1. So we know it has to be is odd. So we can't have this, and we can't have this. And 18 and 1 is a 3-digit number, so it can only be 2 and 9 or 6 and 3. I believe the answer, it can't be 2 and 9 because we know it has to be a more multiple 3. So that's not multiple 3, so it cancel that out as well. So, but 6 and 3 is a multiple 3, so we can say 6 and 3. Okay, so this is 63. Yes, it's between 0 and 100, so that works. It's an odd number. Yes, it's an odd number. And it's a multiple 3. 63 multiple 3, which works. So it says find the number. There's your number, 63. Question 5. Find the smallest number which is greater than 2000, a squared number, and a multiple 4. Okay. So we got to think of 2000. What number multiplied to give you 2000? Let's try 20, 20. 20 times 20 is 400. That's nowhere close. Okay, so let's try 50 and 50 then. 50 and 50. 50 times 50 is 2500. It's too big. So it must be between 20 and 50. So let's try 45. Maybe 45 times 45 will give you close to 200. So let's try 45 times 45. 5 times 5 is 25. 5 times 4 is 20. Plus 2 is 12. Remember, 0. 4 times 5 again is 20. Wait a minute. Oh yeah, 4 times 5 is 20. 16, 18. Now you add them together, you get 5, 2, this is 9, and this is 1. So 45 is just a little bit less than 2,000, 1,925. So that means it should be 46 then. So 46 times 4. What we're looking for a number that's bigger than 2,000 and is a squared number. So the squared numbers can only be 45 times 45 or 46 times 46 or 47 times 47 or whatever. So let's try 46. 6 times 6 is 36. 6 times 4 is 24. 24 plus 3 is 27. Magical 0. 4 times 6 is 24. 4 times 4 is 16. Plus 2 is 18. All right. This will be a 6. 7 plus 4 is 11. This carry the 1. This will be 1. This will be 2. So 2,116. Now it says find the smallest number which is greater than 2,000. Yes, this is greater than 2,000. A squared number. Yes, this is a squared number. So what else? And a multiple 4. Yes, this is multiple 4. Because if you divide 2116 by 4, you will see that it is a multiple 4. Because the last 2 digit is divisible by 4. That's the rule for divisibility. Okay. 21 divided by 4 will be 5. 4 times 5 is 20. Carry minus, you get remainder 1. Bring it 1 down. 11 divided by 4 is 2. 2 times 4 is 8. Take away, you get 3. Bring a 6 down. 36 by 4 is 9. And there you have it. See, it is a multiple 4. You can divide by 4. So find the smallest number. Well, the answer is 2,116. It matches all. It works for all the conditions there. All right, let's rub this out. Next one says, how many common multiples of 3, 5, and 7 are there between 1 and 5,000? So what you got to do is you got to find the lowest common multiple of 3, 5, and 7. So how do we do that? Well, what we can do is we can list the multiples of 7, because 7 is the largest number, right? So we just do 14, 21, 21, 28, 35, 42, 49, 56. What's that after that? 56, 63, and then 70, 70, 77, 84, 90, 91, 98, 105. So which one of these is divisible by 3 and 5? Well, let's look at the divisible by 5. Divisible by 5 is all of these. That one, and that one. Now, which one of these are divisible by 3? Well, if you want to know whether a number is divisible by 3, just add the digits, and if it's a multiple 3, it will be divided by 3. Can be divided by 3. So 3 plus 5 is 8. So let's put it in red. 3 plus 8, 7 plus 0 is 7, 1 plus 0 plus 5 is 6. Which one of these is divided by 3? This one. So therefore, this number, 105, is divisible by 7, divisible by 5, and divisible by 3. So there's your number. How many common multiples? Okay, so 105 is the first lowest common multiple that can be divided by 3, 5, and 7. Now, here's the next part. That's not finished yet. Alright, next part is, we know that 105 is the lowest common multiple of 3, 5, and 7. Now, how many multiples of this number can fit in between 1 and 5,000? Well, we take 5,000 and divide it by 105. How many of them will fit? Okay. Let's see, 105, 500, so this will be 4, I think. 420, take away, you get 80, bring a 0 down. I believe this will be 8, 4 times, 8 times that will be, wait, no, 7, not 8, can't be 8. 7. 7 times 100 is 700, 7 times 5 is 35. So therefore, and then if you subtract this, you're going to get, what is it, 65? Remainder 65. So therefore, the 105 goes into 5,047 times. So it does 105, and then it does 210. See, all of these numbers are divisible by 3, 5, and 7. And again, 3, 5, and 7. Next one will be add another 105, you get 315, and then 420, and so on. Okay. And then if you keep going, you'll find out it fits into 5,047 times. And that's your answer. Next page. What is the fraction between that one? Okay. So let's have a look. 6 over 7 and 7 over 9. What we're going to do is we want the top number to be a 13, at least some multiple of 13. Okay. So what we're going to do is we're going to make the bottom number the same first, make the same denominator. So 7 and 9, they're both, okay, 7 and 9, the lowest common multiple will be 63. So this would be, if you times it by 9, you get 54 over 63. And you times it by 7, you get 49 over 53. Now it says what fraction? It's between these two numbers. So it's between this or between this. So what number is between here? Okay, so first of all, what we should do is we should swap them around. 49 should go over here. 49, 63, and then 54 should go over here. Oh, by the way, that should be a 6 down here. Okay, so what number could go between there? Well, all the numbers that can go between, whole numbers obviously, because fractions deal with whole numbers. What whole number can we go between there? Well, we can say 50, add a 63, 51, 52, 53. Okay, so these are the only numbers that can go in between those two ones there. Now, if you want the top number to be a 13, that means we have to simplify it, right? Have to divide it by something, or to get 13. So which one of these can be divided by 13? Well, let's have a look at the multiples of 13. You got 13, 26, 39, 52. So that means that 52 is the one that can be divided by 13. Can get to 13 because you want the numerator to have a numerator of 13. So 52 over 63. If we divide this by 4, you will get 13, which works, which is what we want. We want a numerator of 13. Now you want the bottom number to be, to be the same. Well, not the same, but like you have to divide it by the same number. Because that's how fractions work. If you divide the top number by 4, you have to divide the bottom by 4 as well. So let's see. 63 divided by 4 would give you 15 and 3/4. In other words, 15.75. Okay, so which number here is close to 15.75? And that should be the answer. Well, 15.75 is pretty close to 16, isn't it? So that'll be this one here, and that's the answer. All right, so this will be the answer there. A rectangular piece of paper has size 48 by 60. If equal squares as large as possible are formed inside this rectangle without any gaps, what's the minimum amount? So here's your piece of paper, and it's 60 by 48. So what we do is we find the highest common factor, the HCF of 48 and 60. So what can 48 and 60 be divided by? That's the highest. Well, I believe it's going to be 12. They can both be divided by 12, and that's the biggest number. All right, so that means that 60 divided by 12, you're going to get 5. 48 divided by 12, you get 4. So that means we're going to divide 48 into 4 equal pieces. Like so. And 60 is going to get divided by 5 equal pieces. 1, 2, so as you can see here, 48 is divided into 4 equal pieces, and each one is 12. And 60 is divided into 12 as well, and 5 equal pieces. And as you can see, this is 12, and this is 12, meaning this is a square. So we got a square. We want a square inside. Okay, so that's a square. Now it says, if equal squares as large as possible are formed inside this rectangle, which is what we did, without any gaps, what's the minimum amount? Okay, so how many squares are there? Count it and then get the answer. Question 9. Trees are to be planted equal distance surrounding a rectangular field. Now, it says surrounding a rectangular field. All right, with sides of 12 and 16. If a tree is definitely planted at each corner, so each corner, got a tree. What is the least number of trees planted? So what we're going to do is, if you want a least number planted, you have to find the highest common factor. Highest common factor of 12 and 16. What can they both be divided by? Well, the highest number you can divide them both by is 4. So that means we can have a gap of 4. So let's see. What's 12 divided by 4? You get 3. You get 3 gaps. So like this. And then what's 16 divided by 4? You get 4. That means it's going to jump 4 times. 1, 2, 3, 4. Make it a bit smaller. Okay, so that means the trees there and trees there. There you go. So that means you're going to have another tree here, 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 and here. Like that. All right, just count how many dots are there. Those are the trees. The dots are the trees. And if you count all the dots, you get the answer. Okay, moving on. 70 tiles, each measure 3 by 2. What is the area of the largest square possible using these tiles? 3 by 2. Okay, so here you got a rectangle. That's 3 by 2. Now it says, what's the area of the largest possible square using these tiles? So if you want to make a square, you got to look at 2 and 3, and what's the lowest common multiple? The lowest common multiple is 6. That means that we want 6. So if I want to make a square, I need 6 here and I need 6 here. All right, so to make 6, I need 3 and 3. That makes 6. Now to make 6 on the other side, I need 2 here. That's 4, another 2 here, and that's 6. There we go, we have a square now. It's 6 long and 6 wide. Okay, so there's your first square. Now, you have 72 of these. So how many squares can you make? Well, what we want to do is we want to make these squares here. Okay, here's one square. Now, how do you make another square? How you make a bigger square? Can I use 2 squares? Is that going to be a square? No, it's going to be a rectangle. So so the first time you make a square, you can have 1 square. If you want to make a bigger square, you need 4 of these squares to make another square. If you want to make an even bigger square, you need 3 and 3. All right, so so you got 1, or you could have 4, or you could have 9, and so on. Okay, so that means that to make squares out of squares, you need the power, like squared numbers. So this is 1 squared, 2 squared, 3 squared, and so on. Suppose I want to make another bigger square than this one here. I have to do 4 and 4. Okay, that means I go to 16, which is 4 squared. Okay, so let's see how many. I've got 72. So now to make one square of this shape, you need how many? 6. 1, 2, 3, 4, 5, 6. You need 6 of these tiles. So 6 tiles make 1 square. How many squares do we need? Well, 72 divided by 6 will give you 12 squares. You got 12 squares. So with the 12 squares, what can I make? Can I make 1 square? Yes. Can I make 4 square? Yes. Can I make 9 square? Yes. Can I make 16 square? No, because 12 squares. To make this last one here, you need 16 squares, but you only have 12. So you can make this one here. You can make the 9. You have some left over, but it doesn't matter. You can at least make that shape. So that means you have. It says, what is the largest square possible using these tiles? Largest square possible. Well, let's rub this part out and I'll show you. All right, so we know that we need 6 squares, so 6 tiles to make 1 square. And we can make how many squares do we need? We need 9 squares, which means 9 times 6, 54 tiles. Let me see. Now, if you have 54 tiles, well, let's have a look. Now, the area of 1 square, is, again, I'll have 3 like this. I have 6 by 6. The area of 1 square is 36, isn't it? So and you got 9 of those squares. So that means 36 times 9. 6 times 9 is 54. 9 times 3 is 27. 27 plus 5 is 324. There's your answer there. Next page. 12 chickens and 12 chickens and rabbits have 40 legs altogether. How many chickens are there? So you got, we got chicken, and we got rabbits, and we have a total. This will be the animal count, and this will be leg count. So, what's the total animal count? There's 12 animals altogether. How many chickens and rabbits? We don't know yet. We can guess and check. How many legs do we have altogether? We got 40 legs altogether. So let's try 6 and 6. So 6 chickens will be... Now chickens have 2 legs each and rabbits have 4 legs each. So how many legs does all the chickens have altogether? I'll put that in blue. 6 times 2 is 12 and 4 times 6 is 24. Does that add to 40? 36 is close, but not yet. Now you want the number. We got 36 altogether. We want 40, right? We want it. So this number 36, we want it to be higher. To make it higher, you have to increase the rabbits. Okay, so I'm gonna increase the rabbit maybe to 8. I'll try 8. Okay, so let's rub this out. Before the rabbits, we guessed 6, but let's guess 8 instead. Let's make it higher. If there are 8 rabbits, there should be only 4 chickens, because 8 plus 4 will give you 12. Now, if you have 4 chickens, 4 times 2 is 8. So 4 times 2 there. It's going to give you 8 legs altogether. Rabbit is 8 times 4, and that's 32. Does it add to 40? Yes, it does. So we've guessed correctly now. It says, how many chickens are there? Well, the chicken is, there are 4 chickens. In the number pattern, what is the 18th number? Okay, it goes 1, 3, 5, 8. Then repeats 1, 3, 5, 8. Then repeats 1, 3, 5, 8. So we're going to take the 18th number, because these are all the numbers. So there's, or actually, you know what? It's not even that long. You can just write it out if you like. You can just keep going. Okay, you can say 1, 3, 5, 8. So this is 3, 12. This is 13, 14, 15, 16, 17, 18. The answer is 3. You can just get the answer there. So the 18th number is that one there. 6 boys stand in a line. Otherwise, if they give you a really big number, you know, all you gotta do is take that number. So, for example, 18, you divide it by 4. You get 4 remainder 2. Okay, the remainder tells you what number it is. If it's remainder 2, remainder 1, remainder 2, remainder 3, remainder 0. 1, 2, 3, 0. Every time you get remainder 2, you'll always get a 3. Every time if you get remainder 1, you'll always get a 1, and so on. Okay, that's the other method. 6 boys stand in a line. How many ways can they stand? Okay, six boys. So we gotta think of the positions and the people. So these are the positions they can stand. How many boys can stand the first position? Well, there's 6. 6 boys, so any 6 of them can stand the first position. How many second position? Well, there are only 5 left to stand in there, because the first boy is already in the first position. Then there's only 5 boys to stand in the second position, and then there's 4, 3, 2, 1. What do we do with these numbers? We multiply them. Done. For every $2 Anna receives, Jenny gets $3. So this is ratios, okay? So you got Anna and Jenny. And you think of them like in terms of ratio. So this is Anna has 2, Jenny has 3. How can you divide 60 between the 2 girls? Okay, so think of the ratios as cups. You got 2 cups and you got 3 cups. Now you're going to take $60. You're going to take $60 and you're going to divide it into, give Anna some and give Jenny some. And it has to be divided evenly into all these cups. Okay, so what we do, we take 60, we divide by how many cups there are. There are 5 cups, which means 60 is divided by 12 is 12. So each cup contains 12. Okay, now it says, how can you divide it evenly? Okay, well, 60, so each one is 12. Anna has 2 cups, 2 times 12 is 24. And Jenny has 3 cups, 3 times 12 is 36. So therefore, Anna gets $24 and Jenny gets $36. This is a ratio question. Next, at a party, 2 guests shake hands exactly once with each other. How many handshakes are exchanged altogether among 8 people? If there are 8 people, all you gotta do, here's a formula. Handshake formula. Handshake formula is equal to n times by n minus 1 divided by 2. So if you have 8 people, n equals the number of people. So if you have 8 people, so if n is equal to 8, then you just do this. You get 8 times 8 minus 1 divided by 2. So this is 8 times 7. So it's 8 times 7 divided by 2. 8 times 7 is 56. 56 divided by 2 is 28. There are 28 handshakes and you're done. So the answer is 28. Okay, use the formula. Handshake formula, use that. Janice wants to wrap a cube with sides 5 centimeters. How many gift wrap does she need? You have to find the surface area of this cube. The cube is 5 by 5. These are all 5. Now, what you want to do is find the area of the front face. What's the area of the front face? That's 5 times 5, which equals to 25. What's the area of the top face? 25. Area of side face? 25. They're all the same, right? How many faces does a cube have? A cube has 6 faces, so 6 times 25. And you get the area of all the surfaces, which is 6 times 25. You worked it out. Question 7. How far will a car travel at Now we have this question, which is distance over speed times time. It is how far. How far means a distance. So you need to find a distance. You need to find this one. To find a distance, you cover it and you say the answer is speed times time. The speed is equal to 54. And the time is equal 54 kilometers per hour. And the time is 3.5 hours. So 54 times 3.5 and work it out. All right, next one. This one is asking you to find the area and perimeter. The area is, you can cut this shape into two shapes. So now you have 17 times 3, which is equal to 51. And then you have, what is this? This is 9. 9 times what? If this is 15 and this is 17, this must be 2. 9 times 2 is 18. So now the area is equal to 51 plus 18. Work it out. Now the perimeter. I'm going to put in all the values for you. This is going to be 2. This one is going to be 9 plus 3, which is 12. You have all the sides. Now to find the perimeter, just add them all up. So 17 plus 12 plus 2 plus 9 plus 15 plus 3. Work it out and get the answer for perimeter. Next one is a racing car driver was traveling the distance of a football field each second. If a football field is 100 meters long, how fast is this person driving in kilometers per hour? So this person is going 100 meters. It says a racing car driver was traveling a distance of 100 meters per second. It says each second. Okay, each second. How fast is this person driving in kilometers per hour? So they want a kilometers per hour. All right. So if you want to turn it to kilometers per hour, how do you go from seconds to hours? We times it by 3,600. So if you want to do that, you got to times this one also by 3,600. So 3,600 times 100 will be what? 360000, and that gives you 360,000 meters. Obviously, this is in meters, this is in meters. Now turn to kilometers, cross out 3 zeros, and you have 360 kilometers. So the answer is D. Find the sum of 3% of 5 and 19% of 4. So 3% of 5 meters. Okay, I'll do the working out down here. So 3% of 5 meters. Let's change this to centimeters. This will be 500 centimeters, right? So 3% is 3 over 100. Of means times. 500 is 500 over 1. Now that we're multiplying, we can actually simplify. We can cross out the zeros. 1 top, 1 bottom, 1 top, 1 bottom. So now you have 3 times 5 is equal to 15. 1 times 1 is 1. 15 over 1 is just 15. That's just a whole number. So it says find the sum of this thing, which is equal to 15. We just worked it out. And now we got to work this thing. 19% of 4 meters. So 19% of 4 meters, which is 400 centimeters. That's 19 over, whoops. This is going to equal to 19 over 100 of, it's going to be times 400 is 400 over 1. And now you can cross out the 0, 0, 0, 0. That's 19 times 4. 20 times 4 is 80. 19 times 4 must be 76. So now you got 76 for that. Now this will be in centimeters, obviously. Now it says find the sum. The sum means you're going to add these two up together. Okay. Next question. Last exam, I'll let you add those two up and get your answer for question 2. Question 3. Last exam, I scored 12 above average. This time I scored 8 below average. Both averages were the same. So the difference in my 2 mark must be what? Last I scored 12 above average. Okay. Oh, both averages were the same. So in one test, let's say the average was 50. Something like that. You had 12 above average, so you had 62. And this time I score 8 below average. 8 below. So this would be a distance of 8. This would be a distance of sorry, this is distance of 12. This is 8. So 50 take away 8 will be 42. So the difference in my my 2 marks must be the difference in my 2 marks. Oh, the difference means like how far away is from the 2 marks. One is 62, the other one's 42. So 62 take away 42 is 20, and the answer is D. All right, next one. Today the sum of age of my son's age. Today the sum of my age and my son's age is 52. Okay, so they forgot to put the word my. The sum of my age and my son's age is 52. 4 years ago, so let's say, this is a dad and son. This is now. This is 4 years ago. So we know that the total between dad and son now will be 52. 4 years ago, I was 3 times as old as he was. So 4 years ago, so this is 4 years. So imagine let's call this age, let's call the son's age question mark. We don't know what his mark is. We're going to start with him. The dad's age is three times as old as his son's age 4 years ago. So that means the dad's age must be question mark plus question mark plus question mark. Okay. Now, at the moment, this is 4 years ago. So now you're going to have whatever your age 4 years ago. That's three question mark. You add 4 because this is 4 years later. Going to be 4 years older, right? Whereas the son will be whatever the question number is plus 4. And that equals to 52. Now it says, in how many years will I be twice as old as he is? How many years? So we have to work it out. All right, so let's use this information here. To work it out how old each person is, okay? So let me just get rid of this. We don't need this anymore. All we need is this part at the top here. All right. I know that if I take all of these question marks and I add them up, and I add the 4, and I add the question mark, and I add another 4, I'll get 52. Because the dad's age and the son's age must equal to 52. That's what it says. So what can we do? Well, let's just rearrange it so you got all the question mark together. You got 4 question marks now, isn't it? And plus 4 gives me plus 8 equals 52. What plus 8 gives me 52? So 52 minus 8 would give you what, 14? No, 44? So 44 is equal to all of that. Actually, I'll put 44 here. 44 plus 8, 52. So therefore, each of those question mark must equal to what? 44 divided by 4 is 11. So that means that the question mark is equal to 11. So now the son's age is 11. 11 plus 4, which equals 15. So now the son's age is equal to 15. And the dad's age is, well, this is 11. This is 11, 11, 11. That's 33. 33 plus 4, 37. All right, we worked it out. 4 years ago, how old would... Now, let's check to see if it's correct. So 4 years ago, let's put this one back in. We know the numbers now. 4 years ago, the dad would be 33 and the son would be 11. And obviously, the dad is 3 times older than the son, which makes sense. Now, it says, in how many years will I be twice as old as my son? Okay, so twice, huh? I think it's 3, but we'll just double check. So so this is now, so 1 year later, 2 years later, 3 years later. Let's check it out. 1 year later, your dad's going to be 38, son's going to be 16. Is 38 double 16? No, it's not. 2 years later, so this will be 39 and this will be 17. Is that? Nope. How about 3 years later? This will be 40 and this will be 18. Double 18 is 36? Nope. Okay, it's 4 years later. 42, 19, nope. 5 years later. 40, oh sorry, this is 41, my bad. 42, and this is, wait, what? 17, 18, 19, 20. 5 years later, yep, 20 and 42. That's still not correct. All right. 6 years later. 6 years later, you're going to get 43 and 21. 7 years later. 7 years later, you got 44 and 22. Yes, there we go. 7 years later is the answer. So the answer here will be none of these because they don't have 7 years later here. All right, next one. These are pretty hard questions. How many boxes measure 2 meters by 3 meters by 4 meters could be stacked within a room measuring 8 by 9 by 15? Okay. So here's your room. It's 8 by 9 by 15, and it says how many of the 2 by 3 by 4? 2 by 3 by 4. Okay. I'm going to draw the small one. 2, 3, 4. So when it comes to how are we going to stack this? 8, 9, and 15. I guess you could put the 2 over here. 2, you can have 4 of them. And then for 15, I'll put 3. Oh, no, 5. I'll do, so this is 2, I'll do 3 here, and 3. And and that one 3. Okay. So 2, 3, and that means that the width must be 4 because it's 2, 3, and 4. 2, 3, and 4. 4. How many 4s can go into 9? Well, only 2. So 2 layers of this. So you got how many? You got 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 times 4 is 20. So you have 20 of these. And there's 2 layers. 20 times 2 is 40. So you can have 40 of them. I wonder if there's another rearrangement we can do. Let's try, instead of 3 that way, let's do 3 this way instead. So this will be a 2, 3. If you stack 3 that way, how many ways can you stack upwards? Well, 15 divided by 4. 15 divided by 4. 15 divided by 4 will give you 3 and 3/4. So that means only 3. 1, 2, 3 high. If you want to stack it high, you're going to stack 3 times. Gonna have a lot of gap here. Anyway, 3 times 3, which is 9. 9 times 4 is 36. So 40 is still better. So if you rearrange it in a different way, you only get 36. Alright. I think 40... I wonder if we will do one more. Let's try another one. Actually, I used to do rubber. Alright, instead of putting 2 across that way, let's put 4 across this way. That means 4, you're going to have 2 then. So this will be 4 and 4, which makes 8. Now, if you want to do that, how many ways can I put... Nah, I think the answer is 40. Try not to think too much into it. Okay, let's do these ones. Stacy, Courtney, Evan, and Gregory are planting white pines, red buds, flowering crab, and oak tree for Arbor Day. They're planting 24, 3, and 2 trees each. Dig into these clues discover. Stacy and will get her dad to help, and together they plan on planting more than the girl planting So they're talking about girls and boys again. So let's establish who's boy, who's girl. This is girl. Oop. Wait, what? Courtney, girl, Evan, boy, Gregory, boy. We don't need this. All right. Stacy will get her dad to help plan on planting more than the girl planting the flowering crab, and the boy with oak tree, but fewer than Gregory. So Stacy is more than one person. So this is Stacy. Oh. Stacy. She is. They plant more than the girl, so more than someone. There's more than one person. And the boy, so this is a girl and this is a boy. So more than two people, but fewer than Gregory. So Gregory must be more than Stacy. That's Gregory there. So Stacy must be in the second position. This first, second, third, and fourth. So that means that if there's the first, second, so that means she is in position, Stacy must be 4. And Gregory must be 20 because he's going to be the most. Courtney will plant fewer than Gregory. Courtney. Oh, by the way, this must be Courtney because she's the only other girl, and then the boy, this one must be Evan, must be other boy. So that means that Evan must be the last one, which is the 2, and Courtney must be 3. It says Courtney will plant fewer than Gregory. Courtney will plant fewer than Gregory because Gregory is first. And the girl planting red buds. Oh, so the girl, so she's fewer than Gregory, another girl. Obviously the other girl is Stacy. So Stacy must be the one that has the red bud. But more than the boy planting oak. So Courtney's more than Evan, and Evan is the other boy that's planting oak. So Evan must be the one doing oak. Now let's go back to, that's all the clues there. Let's go back to the first one. Stacy will get her dad and to help, and together they plan on planting more than the girl planting flowering crab. So Stacy's planting more than the girl, which is Courtney, and Courtney wants to be the one planting flowering crab, and then obviously there's only one left. So Gregory must be the white pine. There. Okay, all done. Next one, let's see, Brianna, Angela, Jenny, the boy. Okay, so let's see, Brianna, I'm assuming that's a girl. Angela, girl. Jenny, girl. David, boy. Lisa, girl. And John, boy. Only 2 boys. Brianna, listed. Angela, listed. Jenny, listed. So Brianna, Angela, and Jenny. They're all listed. The boy who unplugged the coffee pot. That could be anyone. So the boy who the boy who unplugged the coffee pot. So the coffee pot, where's the coffee pot? Coffee pot was not done by Brianna, Angela, or Jenny, or Lisa. It has to be a boy. Okay. And the boy who stores information on the computer. So the one who does computer must also be a boy. So it can't be these people here. Can't be the girls. Okay. David, Lisa, John. Okay, so now let's do the again. David, Lisa, and John. The girl who locks the door. The girl who locks the door. So the door. We know that's the girl who locks the files and the girl who turns off the copier. So David, Lisa, and John cannot be the one who did the door. Cannot be the one who did the lock the files. And cannot be the one who did the copier. All right, and as you can see there, already we have one. Lisa must be the phone because everything else is not there. So Lisa has to be the phone. If she's the phone, we can cross out all the other people for the phone. And yeah, we haven't got another clue yet. All right, next one. Oh, it says David, Angela, and Jenny. The boy who stores information on the computer. There's only one other boy that's not listed. That must be John. He must be the one who stores information on the computer. So he must be the one that tick here, computer. If you tick it there, you must cross this one out and this one out. And if you do that, that means this will come out to be true. Okay, now what else? The boy who stores on the computer, so we did that. And the girl who turns off the copier. Who's the one who turns off the copier? Oh, it doesn't matter who it is. All we know is that whoever turned off the copier cannot be David, Angela, and Jenny. So David, Angela. The copier cannot be David, Angela, and Jenny. So that one cross and cross. Angela does not lock the door. So Angela did not lock the door. So we crossed out Angela for the door. Then it reveals to us that she's the one who did the files. And if she did the files, we can cross out all of these other ones, which means that Jenny is the one who did the door. And if Jenny did the door, then we know that Brianna did the copier, and you're done. Okay. All right, last one. Oh, this one again. All right. Taylor, let's first establish who's boy, who's girl. So Taylor, boy. Matthew, boy. Damon, boy. Perry, boy. Justin, boy. Actually, these are all boy. Never mind. Sorry. I didn't read the question properly. All right. Taylor and the boy. So when it says Taylor, it means it lists the person Taylor. So Taylor is already listed. So it can't be anything else after you put a comma. He's not doing all the other stuff. The boy who spotted a goose beak. So Taylor cannot be the one that saw the goose beak. So put a cross on goose beak and Taylor. And the boy who sighted the cardinal. So Taylor can't be the one who saw the cardinal. And the boy who saw a thrasher. So Taylor can't be the one that saw the thrasher. Share a pair of binoculars. Matthew. So Matthew is the next one to be listed. And the boy who saw the killdeer. So Matthew can't be the one that saw the killdeer. And the boy who spotted a robin. So he can't be the one that spotted a robin. All complain of being hungry. All right, next one says Damon. So Damon, Cortez, and... Okay, it's named Cortez. The boy who found a cardinal. So they can't be the one who found the cardinal. Where's the cardinal? Yeah, cross and cross. The one who spotted a blue jay. So they can't be the one who spotted a blue jay. And the one sighting the thrasher. So they can't be the one who saw the thrasher. Study the next. Okay, next one. Next one is Justin, Ty, and Dane. So Justin, Ty, and Dane. Yep. The boy spotting a killdeer. So they can't be the one who saw the killdeer. The boy who saw the grosbeak. So they can't be the one who saw the grosbeak. The boy who spied the robin. Okay, so no robin. And the boy with the blue jay. So they can't be the one with the blue jay. Where's the blue jay? Here. Okay. Earning points for whatever. Taylor, next one says Taylor. Where's Taylor? Here. The boy who saw the killdeer. So Taylor can't be the one who saw the killdeer. The boy who saw the marten. Okay, that can't be the one who saw the marten. The boy who saw a cardinal. So he can't be the one who saw a cardinal. The boy who saw a blue jay. So blue jay can't be Taylor as well. And Perry. Oh, so the last person's Perry. So that means that Perry... Oh, so they're both listed. So that means that Perry is also... Should have also been listed. Okay, so I'll do it again. Taylor and Perry. They should have put Perry at the top here, but whatever. The boy who saw the killdeer. So that means Perry can't be the one who saw the killdeer. The boy who saw the marten. So it can't be the marten. Cardinal, can't be a cardinal. And Blue Jay, can't be Blue Jay. All right, so after we cross all of that out, you can see that here, out of all of them, there's only one left. So this one must be a tick. Once you tick that, you can cross all of these out. All right, and hopefully it will reveal something else. Okay, it didn't. So we continue with the clues. Matthew, Perry, and... All right, so next one we just do Matthew, Perry, and... Matthew, Perry, and Dane. Okay, Dane. Okay, now it says the boy sighting the mockingbird. So they can't be the one who saw the mockingbird. Where's the mockingbird? So we crossed it out for mockingbird. Oh, no. Matthew. Okay, so Perry and Dane. Perry and Dane. So they can't be the one who saw the mockingbird. And the boy who spotted the grosbeak. So they can't be the one who saw the grosbeak. Yep. Careful not to disturb the bird's nest. Okay, next one. Let's do the next one. Yeah, not enough information yet. Next one says Dane, Ty. Okay, so Dane and Ty. And the boy who spotted a marten. So they can't be the one who spotted the marten. Building birds. Okay, now hopefully we got some information in that we can tick. I can't see anything yet. Must have missed something. Let me look at this other one again. No, not that one. It was six. Tyler and Perry. So Tyler and Perry. The boy who saw the killdeer, so okay, can't be killdeer. The boy who saw the marten, they can't be the marten. The boy who saw cardinal, yep. And the boy who saw blue jay. Okay. Matthew, Perry, and Dane. Matthew's already done. What am I missing? Perry. Alright. Tyler and the boy who spotted a grosbeak. Grosbeak. Robin or Thrasher, Perry. Oh, Perry. How did I miss that? Jesus. Okay. I don't know how I missed that. Damon, Perry, Damon, Perry, and Justin. The boy who saw Killdeer, they can't be the one who caused Killdeer. The boy who spotted Robin, they can't be the one to spot a robin. Why didn't I put that there? And that one there too. Jeez, I missed that. Oh my god, I can't believe it. If that's the case, then that means this will be true. And that, and that. And if that's the case, this will be true. This, and that will be gone. Something is missing. Oh, yep, I see it. That's true. This will be true. This will be true. Oh, great. Now which one is which? Damon and Cortez. Damon. Okay, so Damon Damon, Grosbeak, and Killing. Okay, Damon, Grosbeak, Damon. Oh, Cortez. I think Damon is mentioned here. And here. And nowhere else. So hopefully these will provide enough information. I must have missed something. Damon, Perry, Damon and Cortez. I don't know. Blue Jay, Thrasher, Robin, Killdeer. Oh, Damon can't be the one that saw the Killdeer. What? That means this is the case here. Done. Okay, finally. The first one is Taylor with a Robin. Matthew, Blue Jay. Grosbeak is Damon. Perry is Thrasher. Justin is where is he? Martin. Cortez is Killdeer. Ty is Mockingbird. And Dane is Cardinal. Done. Oh, finally. Alright. I hope that helps.